you. Is my mic on? Can everyone hear me in the back? Waves from the back? Yes? Yes? A bit louder? Can let's see. Hello, hello. Better now? 1, 2, 3, testing. Hello, 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 hello. Louder? Is that good? No? He's tuning it. Oh, okay, yes. Everyone can hear me now. Yes? Everyone can hear me? Good? Good? Okay, let's talk about GraphQL. That's an amazing tool. Okay, I was gonna present myself, but I think I'll leave it for the last talk because you're gonna see me twice today. Unfortunately for you, see my ugly face 2 times, but well, we are gonna survive that. So first things first, we are gonna talk a lot about Star Wars during this talk. So you guys like Star Wars? Yeah? Awesome. Was afraid nobody would like it. And then for those who never heard of GraphQL, well, GraphQL is an API. So put your mindset now to REST APIs, RESTful JSON APIs, or XML APIs, SOAP. No one likes that. But well, just put a mindset to APIs and let's talk about it. So okay, when we have an API, we want to check a few things, of course. So let's say we want to select our dear Luke Skywalker. Of course, our hero, so we should select it. But then sometimes we want to bring some other data with it. So let's say we want to get Luke Skywalker, but we also want to have some information about which world Luke Skywalker is coming from. But we also want to know which cool spaceships Skywalker actually drives or flies around the space. So how this would like, oh, and also of course we want some data on Luke Skywalker himself. So how this would like in a traditional API. We would first go, okay, get me the list of people that we saw before. Now you get me Luke. Luke is my ID here in this case. So that's another get. Sorry, the contrast is not too good. Here is saying get. And then we want to have 2 more queries to our API. One is getting Tatooine, which is the word from Luke. And the other is like a pagination to bring all the starships that Luke actually flies around the universe. And then we want to also get some details for those starships. Okay, this looks like a lot of queries, and this problem has a name. This is called N+1 issue. Have you guys heard of it? Yeah, so that's the case when we have to wait for one query, for one procedure to start the next one. So when we have our classical RESTful APIs, we are going to go get the people, wait for my response, parse it, get my next item, which is going to be Luke, and then parse it, and then get my next item, and then there you go. So here we are going to have at least 4 to 5 iterations with our web server, so that creates a lot of bottleneck. So GraphQL was actually designed to prevent HTTP overfetching. So how this will look like, so we actually like to have some tailor-made APIs, right? So many people get, for example, the REST APIs and get all those queries we have seen before, and they create like a giant endpoint, like get me everything about Luke, let's say. And then this API is going to have like a giant JSON response. So this is also known as RPC. So, but in GraphQL, it's a bit different. Let's now get a bit into what GraphQL works. So first, we have a query, as the name say, graph query language. And then we have a result, of course. How a query is going to look like. So every query you send to a GraphQL server is going to have a keyword called query, and then you can give it a name. In our case, we are going to give it Luke Skywalker. Pretty nice. So then the first thing, we want to get the data from Luke himself. So we just pass this little guy here, which is a query, an internal query. I'm going to show you better afterwards. An ID, and then we are going to now start asking for some data. So from Luke, I wanted the name, I wanted the birth year, I wanted the height, I wanted the hair color, I wanted now my starships connection. That's when things start to get cool. Because you don't have only to get to one level of information. You can go to nested levels. So in here, we call this one as starship connections. And starship connections has a starship inside of it, which then you can keep going. And then I can ask for the name of those starships. As we can see her name. And then this results in 2 starships in case of Luke. If we're selecting other characters from Star Wars, we would see like 2, 5, 10 other starships connections. And then we also want to have another connection here, which is the home world. So that's another query you can make inside of a character, which is Luke. And then we already have here the name of the world. So this thing actually can go on and on. So let's say you want to see Luke's friends, you want to see more people from the planet he's coming from, so you could, in home world, come and say people from Tatooine. So this can go forward and forward. So is this good? You want some time to digest this one? No? So what happens in this case, I think it's really cool. Actually, GraphQL makes this beautiful thing. The clients start loving your API. Because I think one of the hassles when you are actually developing an API is always like yourself or the front-end guy or the other company doing the front-end asking, hey, can you add this new field to that API that you have? That endpoint, oh, I needed one piece of information there. And then you have like to go all through your development cycle, release cycle, just to put a bit more of information in your API. And GraphQL actually solves this issue just by giving you the power. The client now has the power to ask the information. Of course, we can limit those. We're going to see this afterwards. Let's see some other cool examples here. One of other things we can do with GraphQL, of course, is pagination. We have to have some kind of way to limit our data to get a subset of data. So let's query for the good movies, because we all know the good movies in Star Wars are only the first 3 movies, 4, 5, and 6, of course. Oh, this sounds better now, right? Okay. So, okay, all films, which is another type of query, is going to have a sub-item called films, which then we can again start asking for more data. In this case, we are asking for the first 3 films. So this already is a pagination. So this query here, the all films, it has a special arguments inside of it. In this case, for paginating it. So then I'm asking for the 3 first films. So I get 4, 5, and 6 episodes, 4, 5, and 6. So all the good movies from Star Wars. That's pretty nice. But let's say, for example, our example before was only doing this, right? We were only getting the first subset of data, only the first 3 items. But let's say we want to go a bit further in our pagination, a bit further in our data set. So let's say I want to get those 3 characters. On GraphQL, we need to start some kind of pointer. Just like you have limit of set on SQL, we need to set, okay, how do I make a pointer here? In this case, we have our 2D2. So what could I say to GraphQL? Okay, get the first 3 items after our 2D2. And then from there on, you can always have like subset of data and then keep going forwards and backwards, just like this. So I can also ask, hey, give me the 3 characters before our 2D2. And that makes it really powerful for you to navigate through the whole data set that you have. Well, let's see how this would like in a query. So we would have, again, the same query. All people, first 3 after R2D2. Now you're going to see something a bit different here, which is the edges. Edges means this subset of data is actually a proper pagination. So what you see here, node, actually translates to people, to a person. This name is protected, so every time you have a specific pagination inside GraphQL, you are going to have those names here, edges and nodes. But when you start asking for the node data, like name, ID, you start seeing the same things. This would be nice, but that's not exactly how it works because of this little problem here. We cannot point to our duty2 directly. And that's how GraphQL works. It uses relay cursor pagination. Have any of you used relay on JavaScript Word, relay framework, something like that? Nope? Okay, so that's new information. That's good. So how this actually works, again, the same query. We are going to get now, again, the name of those characters. And then we are going to query also this little information here called cursor. So the cursor is this ugly string, which then we can get it from here and set it in the after place. So instead of naming our duty2, I'm only getting this cursor. And it's important to realize this cursor is dynamic. So it might change on requests. It might change from the first time you make the query for the second time you make the query. So that's why your client has to do it dynamically. So you ask first for the first set of data, and then together with the cursors, so then you can keep moving in your data forwards and backwards. We can also do this for complete pages, for example. So for example, we have all people, and then now I want to say, okay, how many people do we have? So we have 82 in our database here. And then we can do it now in a more complex way, which is also really nice. Instead of marking toward DD2, we are going to now mark our cursor, our connection, to actually what we retrieved before. So the GraphQL server is going to be smart enough to know, okay, this client got now the first 3 items. Now I know if they ask for the next items, I will start from the number 4. I'm not starting from the number 3. And they manage it via the backend. So then we have now the page info. And then you have has next page, has previous page, start cursor, end cursor. And then those 2 guys here are the ones we are going to use for the next queries. So now I can just come, okay, I wanted the first 3 people after this end cursor. So then I can always keep going on pages now. So this gives you control. And then the idea is that your client has already solved all the pagination issues, because as you can see here, we have the has next page true. So this means your client, your pagination, like you can always click on the next until the has next page says false. So all these kind of things we do in the front end, trying to control how many pages are available and dividing by the number of items in the page and etc. This is all gone with relay cursor. The backend is already doing all this work for you. So and then the idea would be to go until we have next page is false. So why do we actually use relay pagination? You might think it's a bit overkill, all these edges, pages, and etc. But it's actually really good for dynamic data. Have you ever wondered, for example, you have, I don't know, 1,000 friends on your Facebook, and you're there just scrolling down, and then you never get duplicated posts? You might have got some in the past, like for some bugs, but then you are scrolling and Facebook always knows where you stopped. This is all because of this kind of relay technique. So the server actually knows what it served to you, how many items, and then knows where to continue from that. So you can get data getting input in your data set, and still the pagination is still going to work. Sorry. Imagine, for example, in a normal limit of set in your database, if someone puts a new row in between your limit of set queries. In a certain moment, you're going to have 2 pages with the same item duplicated. And that's what the kind of issues this prevents. So in a big load of data, you're not going to have any issues. So this idea we saw before, it's a bit weird, but it's actually just a base 64 string. In my case, it means array connection 0. But you should not decode it. You should just keep it secret, because the server is actually the one managing it. In my case, array connection, because the database for the GraphQL API you saw, it's inside arrays, just for being fast, but it could be your database and etc. So don't trust it, never decode it, never try to encode it again. It's just a little tip. And then, of course, one of the main things when we have APIs is actually putting data back to the server. On GraphQL, this has a special name. It's called mutations. So you're actually mutating the data. That's the name, of course. So how we do that in GraphQL? Actually, also pretty simple. So again, instead of having query in the beginning, now we have a mutation just as a placeholder. And then we can give it a name. So let's say we want to create reviews for the episodes, for the Star Wars episodes. So we are going to say which episode's that, and what is the content of your review. But there is one trick really nice on GraphQL. In the same time you can create a mutation, you can ask data back. So when we are creating the review, I can simply say, okay, this mutation can actually return the review content, which is also connected to the movie the person is reviewing. So in the same query, I can send my review and get back all the information that I need for my screen, for example. So imagine the power of that. You're only making one request to your server, and the user not having to wait like this, posting data to your RESTful API and then querying the data again to get the updated information. That's really, really nice. And then as you can see, we used some variables here. Those can also be used on queries. So if you want to make some fancy stuff, this also works. So let's see a more real example on how this mutation is going to work. So we have now episode content and the rating, which is an integer, how many stars we are giving to this movie. And then we are passing the ID of the episode, which we already got before in our pagination, for example. And then the content and the rating, 5 stars. and then the server is going to return something like this for me. So I can already get, this is already accounting, if your backend is working properly, of course. This is already accounting for the new rating you have put in the server. So what we have here is the content of your review, type review that we saw before, the film, a new hope, and then the new rating is now 4. So that's really simple. In one single shot, you can get everything for your user back. So how this works actually behind the scene in HTTP speaking. It's really simple. So we send a JSON to the server. In this case, the query is a string. So the query we send is always going to be like this ugly string. But the variables we sent before, in this example here, those variables here, they are all sent in native JSON. So that's why it's important for you when doing mutations and some queries actually use the variables, because then typing is going to work. And then, yeah, what we see here, so the variables are coming here as native JSON, and then operation is just the name of the query you're sending, and that's how the server is going to see it and answer in JSON again. So there is no wizardry happening, it's pretty simple. But of course, other things that happen when we are doing APIs, errors, of course. So we have to deal with them. GraphQL has syntax errors, of course, because since this is a query language, the user, the client, might be sending some malformation, some ugly code, some ugly query. So then that one's pretty simple. So it just says, oh, for example, your variable episode is supposed to be string, but you didn't send it to me. And then we just point out, okay, this is on the line 2, column 16. So then if you have like a GraphQL tool, you can see where this error is happening. So that's simple syntax error. But of course, we have runtime errors as well. Because, well, might be that the episode's not found. Let's say the user sent a wrong ID. So the query is good, but the data informed is not good. So it was deleted or something happened. So in this case, we can just say, okay, you asked for an episode that is not found. So, okay, this is a runtime error. It comes with a special key errors here, an array of errors, and then you just have, again, the message and the locations. So that actually makes it really really easy to use. Okay, so let's get now a bit to PHP Word, of course. So, oh, sorry, yeah, it's non-readable, but it's saying here like Webonix, GraphQL, PHP. We have actually 2 main libraries for doing GraphQL and PHP. One is this one from Webonix, and the other is from Yoshido. Both of them, as far as I know, are covering 100% of the specs which are created by Facebook. So yeah, together with React, Relay, GraphQL is part also of this bunch of Facebook tech happening nowadays. It's a pretty good library. And then, okay, we have to declare now a type. So let's say now we are creating our server in the GraphQL with PHP. So we want to be able to answer all these Star Wars queries. So we want to create a human type, for example. So it's just you just create an object type, which is a class inside this library. And then we are going to say, okay, type human, and you put a description. And then there are a few things we have to observe on GraphQL. As you saw before, I could start going through nested levels of information. And that's only possible because GraphQL is completely strict on typing. So we always have to get to the Scholar type level. You can never leave something open. So what happens, either every field that you put in your queries, they have either to map to another object, which then is going to map its own fields, or you have to go to Scholar type. So in this case, name is going to be string, and that's it. You can never leave something like in between. So that's actually what makes the language also super strong and super useful. In this case, we are declaring them for human only ID and name to make it simple. And then the library needs a way to understand which data to return when you ask for humans, for example. So in my case, I told you before that I'm using an array connection. So humans is just the array that I have. And then this array has keys. And then that's how I'm resolving this human to my data. But of course, in here, you could be calling your database connection, your doctrine, or something like that. So in the end, it's pretty simple. So this is a string. Again, that's the query. And then if you call the library internally, let's say you're making tests or something like that, you just call GraphQL execute. First, you have to build your schema. So the object fields we had before are going to be built and then created in a schema. And then we send our query. But yeah, I'm only showing you the PHP version. It's a bit complicated, let's say. But in Symfony, it can get really, really simple. So here we are going to see the overblock GraphQL bundle, which is actually the integration between that library we saw before with Symfony. And then things start to get a bit easier now because we can use our dear YML files. So for example, the same character we had before, we can now just say, hey, character, type, interface in this case, and then we say fields, ID, name, both type string. Pretty simple, pretty straightforward. You can make it the same as you do in your Doctrine entities or something else. You can map them to be exactly the same. And then, of course, in here, we want to also make some connections. So let's say we want to, from the character, know every friends they have. So you can just create friends, and then we have here now type character again. But you can see it's between braces. So this means every time I query for friends inside the character, I'm going to have a bunch of other characters. So there's an array of characters. The same goes for films. So every time you query film inside the character, so you want to know which movies Luke Skywalker appears, you are going to have an array of films. Okay, we created this interface, and now we can create the human and just extend from this interface, just like we do in OOP. So in here, okay, now we have human. Now it's going to be a type object. So that's actually going to be a real type inside our GraphQL. Again, same fields because we are inheriting from the interface. So it's going to be ID and name. We just added now home word because every human needs to have a home word, for example. And then the interface, which is the character, the interface we saw in the slide before. This type of is just to indicate human is inheriting from characters. And this happens because, for example, we created the interface in this example because we have also droids. Droids are actually the same thing, also inheriting from character, all the same information, but then we have like a previous type before just to make it really nice. But interfaces are not required. If you want, you can just drop these interfaces and this type off and declare directly your objects inside GraphQL. Pretty simple, straightforward YML in this case. Okay, so GraphQL needs an entry point. How can we, for example, if you remember from the first example, we had like all humans. So how we make this all humans work, all characters, all movies? How can we make that? So we have the query root type. So inside the GraphQL schema, we need to have a query, which is the keyword we saw when we were querying for the information. So we have simply a description here, just a type object again, description, all Star Wars queries, just for the sake of documentation. And then we are going to ask for all humans. What's the type of all humans? It's going to be human array. That's pretty good. So every time you query for all humans, you get that. And then now we have a resolver in the Symfony style. What this means? Now this is simply calling a resolver, which is called all humans. So this is going to be in our dependency injection. I'm going to show you soon how this is going to work. So we have also human, which is just if you want to query a single human. So let's say you have the ID of Luke Skywalker and you want to query it. And then in this case, we use the resolver human and we pass the argument ID. Which arguments does this one takes? Argument ID type string. As you can see here, we have a question mark now because it's a required field. You cannot ask for my GraphQL API a single human without giving me the ID. I think it's fair enough. So first you get all the humans, you find the one you want, you get the ID, and then you send it to me. Or you get everything as well. That's also an option. If you haven't noticed, this is a Symfony expression language. Have you guys used it before? Symfony expression language? Yeah? So you know it can create a lot of power. So resolver is actually a special tag inside Symfony expression language, which is created by this bundle. So that's actually how this bundle is integrating with Symfony. And that's really powerful because you can call other services, you can call your security, as I'm gonna show you later. So let's first get to a new type, which is the mutation, another root type. So almost straightforward, let's not lose a lot of time here. So we are gonna create a review. Since it's a mutation, I expect to have a bunch of arguments. So we are going to send episode, content, and rating, which is exactly the example we saw in the beginning. Pretty simple, everything is required. So this means if your client doesn't send one of this information, you get a syntax error. So if you send it as null, you get a runtime error. So it's really protected. And the type of the return. So that's the important part. So when I'm creating a review, I'm returning to the user an episode. So then we can actually get the rating and etc. as we did before. And also we have a mutation. This one has a new name, calculation mutate order, and that's how it's gonna go. So let's see how we actually make it happen inside Symfony. We are gonna create a service, straightforward, pretty simple. And this one is gonna call human resolver, just a simple PHP class. And then we are gonna send my repository of humans. You could inject your arrays, you could inject another API if you want to. And that's when it gets interesting. So we have to tag this service. This tag is gonna be overblock GraphQL resolver. And it's gonna be called all humans. And which method inside my class is it gonna call? Is this one, resolve all humans. And then when I want to resolve a single human, as we saw also on the definition of my query type, I want to call the resolve human. So if you remember well, the all humans here, inside our query, when we were using the Symfony expression language, it was all humans here as well. So that's how we map both things. So this is the configuration of my queries, which we just saw, and this is how Symfony is going to point to somewhere. So this is to just configuration. Let's get it to the class then. So that's going to be my human resolver class inside your Symfony application, whichever layer you like. I don't know how is your architecture. So let's say you have already injected your repository, properties, you have your service working pretty nice. So we are going to call the resolve all humans, which is the method name we saw in the configuration for the YML, for the services YML. And then we have here resolve all humans, which is typed with argument, which is a class from GraphQL. So then let's say I'm just going to return all humans. So I'm just going to my human repository. Sorry, it's not readable here. Human repository and find all. So I'm basically just going to my database and saying, hey, get all humans. That's what the user is asking. And then we also want to resolve by a single human. So that's also pretty nice. So let's say you have some business logic here, etc. Doesn't matter for this example. But then this time when we go to our human repository, you could go directly to your database or so, and then you say find by ID, human ID. So then that's really simple, straightforward resolvers. So let's say we are going to have in this application 10 resolvers for humans, for words, for spaceships. So, and then you can make also the complex parts. For example, if you have the spaceship and want to resolve by humans, you could just type here, okay, resolve spaceship by human, and then with the human that you want. So it can go really flexible in many levels. This is a simple example for not complicating this talk. So let's say something happens when we are actually returning a single human. The user sent us a wrong ID or something like that. So we can just surround it in a try catch because it's a database connection or an array connection was not found there. And then we say, okay, human not found exception. We just have to translate that to a Symfony exception for the bundle exception, which is called user error. So let's say in this case, Luke Skywalker was dead, and then we say, hey, this human was eliminated. And then we just throw this error. And that's going to result exactly in what we saw on the errors before, showing like, oh, we can't resolve that because this human was eliminated on line 15, column 10, for example. And then we have some possible errors with this bundle, which is the user error, user warning. So let's say the user is disabled for some reason. In this case, Luke Skywalker is sleeping, so we should not take him around. Or we can set a bundle of errors as well. So let's say the user doesn't have permission, something is dead, the world was exploded, something happened in the world of Star Wars. So then we just come and say, hey, put a bunch of errors together, and then your client's going to have all the errors. Okay, so versioning is always something which is a bit tricky as well. Because if you guys have JSON APIs, REST APIs, I bet you've seen something like that, right? How many of you already made the V1, V2, V3? Yeah, you know people hate you because of that, right? And I think your colleagues as well. So actually in GraphQL it's the same. No, just kidding. It's not. Let's not propagate these wrong things around. So GraphQL has a different approach, which is deprecating fields. So you just come and say, hey, yeah, maybe I want to remove the name. Droids doesn't deserve names because they are machines. They should only use IDs. So then we just say deprecation reason. And what happens, since GraphQL is so structured, the client you have running it is going to start receiving warnings. Because, for example, you're going to use like a relay client in your front end, or you're going to use a GraphQL client in your PHP backend to talk to another GraphQL API. This one is going to start throwing warnings. So you're going to see it on logs and etc. You're going to see in the console from your browser. That depends on the implementation, of course. So then you just deprecate it, and then you leave, for example, a date. Oh, this field is going to be removed in 3 months. I don't know. And then you just do it. And then this actually gives time for the developers to see what is getting deprecated and etc. Or you can just leave that field forever, which then is not going to have the new information that you are going to create in your API. It's going to be something limited. So that's pretty simple. It's pretty nice. So since GraphQL has all this typing as well, I didn't talk much, but the schema that we saw happening, it's actually compiled in a final schema, which the clients can fetch it before. And one of the things you can do as a client is actually ask for all the deprecations. So you can just say, okay, go to the type droid for me, and then bring me all the fields and tell me if they are deprecated. So this is an introspective query, as they call, because instead of querying the data, I'm querying the schema. I'm asking GraphQL, hey, tell me what do you have in this server? You can actually discover things. And then, as you can see here, we just see type, fields, in this case, the name ID, the field ID. It's not deprecated, but the name is deprecated. So is deprecated true, and then you just put a deprecation reason. So how cool is that? Imagine how smart your client can be. How much things you can prevent to happen. Because since the beginning of your application, you can already see, oh, wait, the schema was updated on the server, and they are deprecating a couple of fields, and you see it in your development environment, and you can already fix that before anything happens in the future. So that's really, really cool. And since we have all these powers with the schema on GraphQL, we can actually out-document things. So I recorded this small video just to show, the projector is not really giving me contrast here. But we have the root query, and then we can see everything we have declared before. So we can just go like to films, and then see the films connection from a character. And then you can just go on and go on. So this is all available for you as developer. All available for the developers, for the front end from your API. And that's really good. And then you can see, for example, starship type. And then you see every field you can have from a starship. From name to length to crew, and then you see all the types: string, floats, integers, or other objects. As I said before, it has to always go to the Scala level. So that's simply, I think that's simply really cool. And then other thing we can do is autocomplete, because of course we have a typed schema. So let's say we want to do the first query we did in this presentation to get the best movies. So we just go query best movies, all films, first 3. And then the autocomplete, and then let's say I want to only films because I don't want to do the pagination right now. And then I get like title, episode ID, or something like that. And then, well, as simple as that, you already have the result. So imagine you being a developer in the front end and using these things. I guess you would be so happy to have all these features like this. So, well, we can do the same now for people. I want to get like 2 people. I'm going to show you how to do the pagination in this case. So we ask for the total count for all of them, and then page info, as you guys saw in the example. So we have 82 characters, has next page true, has previous page not, because we are starting from 0, from the first character. And then we have the cursor. So we are getting now Luke and C3PO. And then look at here. I'm now getting the first 2 characters after this page. So I get the end cursor, as we can see here, this crazy ID again, which we shouldn't trust it. And then we should just put it there, and now I got R2D2 and Darth Vader, and you can just go on and go on. Of course, I'm doing this manually to show you, but your code is gonna do it dynamically. So I just think it's really awesome that you can do all of this in an API. Sorry if you have OCD, this microphone is never dropping, but that's okay. So a few things that you can imagine, like heavy queries. What do we do with them? So let's say the user wants to get all the words, all the characters, and then you say, no, my server can't handle that. So one of the things you can do is just limit by depth. You just say, okay, you can only go 10 nested levels. You can never go more than that. That's the configuration we have on the normal library. And that's how you can do it with the Symfony bundle. You just, in the main configuration of your overblock GraphQL, security, query max depth 10. So this makes it really easy. So the user can get human, can get a like Starships connection, and then human again, and then go on up to 10 times. You tune it for your server. Let's say you can handle 2, 3, 4, 20. That's up to you. But of course, this is a bit arbitrary. Let's say like a few queries are heavier, a few queries are a bit lighter in your database or in your other APIs. So you want to have a limit query by complexity. That's also really, really cool because this is just an algorithm which gives points to, for example, every scholar field has 1 point in complexity. Every object field has, I don't know, 10 points in complexity. And then it's going to sum up all the information the user is asking and create a dynamic complexity for it. So in this case, we can just say, again, in the bundle or with the library, okay, the max complexity is going to be 1,000. The default algorithm is this one that I told you, like 1 point per item. But we can actually create custom complexity. So let's say when you ask for droids, you have another API that you have to check, like to see if this droid is not being looked by the police, for example. So then it's actually a heavy query. So you don't want your user querying 10 droids at a time or something like that. So then you can just say, okay, a single droid is going to cost 1,000 complexity plus all the complexity that I already have. So when the GraphQL is getting this query from the front end, from the client, it just says, hey, this is too much information you're asking for me. So we are not giving it to you. And then it just stops in that complexity. I think it's really cool. One other things we have to do is security, of course. So sometimes we don't want to give access to certain users. So then, again, Symfony expression language, let's say I just want to give access when you're a super admin. You can only see IDs when this connection to my API is a super admin. So those things here is super admin and etc. You already know it from Symfony. It's just now in the Symfony expression format. So you can use isAdmin, has row, for example, as we are going to see here. So we can just grab a service from our container in Symfony and just say, hey, is it granted row admin? And then you can have row user or any other custom rows that you have. And you just want to make this field available only for admins, for example. In this case, it's just the visibility of the field. In the other case was a limitation of not sending the information. You can do both. And you can set also for the whole object. So let's say humans can only see themselves, for example. So you're going to create a custom service, a custom object in your Symfony application, something that you are creating. And then you're going to call it, and then you're going to say, hey, do you have, can this user access this information? And then you can create any kind of complex thing or simple thing, your own business rules. So that's really cool. And then let's say we want to limit data. 5 minutes away, I guess. So let's say we want to limit some data. Instead of returning all humans when the user asks for humans, I only want to give them powers to return like from the same race. So what can we do, for example? This is an example using Doctrine. You can create a criteria, and then you can say where the race of this user is this, the race they are going to query is the same of the race. I promise it's not racism. It's just for an example. But then let's say humans can only query humans, droids can only query droids. This is a simple example. You could limit your data dynamically with other fields, of course. And then in the end, I just return from the human repository again, find all by criteria where race equals to the race of the user asking for it. Okay, so with all these powers from GraphQL, we also have some tools. So if you use JetBrains, PHP Storm, or any other JetBrains IDEs, you can actually have the autocomplete running directly inside your IDE. So you just have to make this configuration file and put a schema, and then it's going to download the schema for you. And then you can already start just using the autocomplete again for developing it. So it's really good. Atom has also autocomplete. And the tool I showed you guys before is called GraphQL. It's GraphQL with an I in the end, I of interface. Sorry for the colors, but then that's the GraphQL tool. This one makes documentation, just like a Swagger style as well. And this one makes like a modeling map of your whole schema, so which objects communicates to which objects. That's really nice. Oh, yeah, that's not visible, but what happens here, you can also see on the Chrome toolbox, you can see every GraphQL query going out, and then you can see them already with format. That looks pretty nice. And that's it. There are some useful links you can follow. Of course, the official websites, the libraries, and then if you want to try using GraphQL API, you can just visit the site right now during lunchtime and then start querying with the autocomplete and see how it looks like. So, well, thank you. You guys have questions for me?
Вопросы, ребят? Нагрузил, да?
Hi, Sergey. I have a question about how you should deal with query problems when you have some nested entities that you need to collect from database. So you need to make n+1 query for this case, right?
Yeah, that's a really good question, because what we saw being solved here is the n+1 from the client side, so the HTTP one. But you can also use a technique called data loader, which actually uses promises. I don't know if you guys are familiar with promises in JavaScript, which is the idea that you only resolve one thing after you resolve the whole chain. So in this case, we can use data loader, which is a library also offered by the Overblog guys. So then you can basically, instead of resolving directly to your database, you throw promises, and then in the end you can decide what's the best approach. You can make like a big query to your database, or you can use cache, you can have some subset of data. So the n+1 is also solvable in the backend. I must say sometimes it's not that important for the majority of applications, because you're gonna open one database connection, make a bunch of queries, which is super fast, and then close it. Which is better than making a whole application bootstrap and then open database connection and then return a piece of data and then doing it all over again. But it's solvable as well. So, thanks.
Thanks.
Yes, more questions?
Do you have a sandbox to play with these libraries?
Maybe on my last talk, I'm going to show you something about it. Maybe as a surprise. But there are a few easy ways to install it. So you're going to see something about it.
Hello. Can you tell where in query appear a cursor field for pagination?
Yeah,
It store in database or how it's generated?
In my case, in the simple example that I used, it wouldn't show because I didn't configure it. But you can use, the library offers a new type, which I feel objects, which is the relay connection. And then you can use it, it's going to automatically for you create the cursors and etc. But it's going to be a really simple one. It's just going to be like a normal limit offset. If you want to make the cool one, like Facebook does on the timeline and etc., you either do it by yourself or you can use other libraries to manage the cursors for you. But it's simply about returning, when you declare the type, you declare as a relay pagination, and then it's going to happen automatically for you. It's a bit of magic, but it works well. You can not use it if you don't want to, as I didn't use for this example. That's actually a pretty good question. I might update my slides for that. The answers?
Any more questions? Sorry, one more. Do you have some examples with open source project which use query GraphQL in PHP or Symfony?
Ooh, open
source. Just like example, because it's it's really interesting, but I follow up Google it, and there's no more open source project which use it. So it's almost REST API.
Yeah, that's true. I see a lot of them happening now on JavaScript world because they started with GraphQL before us. I don't know about open source projects in PHP and Symfony using it yet. I know on the company that I work for, we do have it running, but it's closed source, so I sadly can't show you. But yeah, I'll try to research some open source projects and give you the link. I might tweet it later.
First of all, thank you for your presentation. It's very interesting. So my question is about cursors. So if I use cursor, all the time I'm getting the same information, right?
It's the same as?
The same, I mean the same information, the same data.
No.
I'm using one cursor and every time the same, or if that some data is changed and I'm using the same cursor, I'm getting another data, right?
Yeah, what the server does in this cursor, it hides some information. So let's say your client asked for all the characters. So this cursor is not on the basic examples, of course, but what you have is like the server is going to store that your session knows 92 characters, for example, and they have like a time frame, so exactly knows what you queried for. So it's like a bunch of metadata. And then let's say someone included the 93 character. So the server now understands that when you queried, it was 92. So your cursor ID is going to have your identifier. So then when you get to the last page and then you try to do it again, you're going to see the 93 guy because the server now knows that for you, you were missing that one character before. But of course, this is not out of the box. That's going to depend on your installation, etc. What you get out of the box is the simply limit of set, and it might not. And the default one is not storing a single ID for you. So many users are going to have the same cursor ID, but it's up to your implementation.
What about if we have? Yeah. What about the same question? But if we have the sorting by rating, and after some click some content it's between one cursor and another cursor. What in this case? Cursor the same? Or?
Yeah, the cursor can be smart to trace all of this. If we check some JavaScript libraries, they already have this kind of thing, so they can know exactly. It's like a snapshot of the previous data that you have. So when the dynamic data is happening, it can be smart enough to decide if it's changing or something for your next page. But of course, in this simple implementation, you're gonna have like some not duplicates, but you're gonna have like if you change the ordering or something goes up and down, you might have some different information because it's basically the default version is just doing a limit of set. But if your application needs certain complexity like that, you can do it, and that's the power of it. I'm not sure which library to use exactly in PHP, but I'm pretty sure there is something already for managing this for you.
Sergey, I have another question.
Where
yeah. As GraphQL is using Post, I think, right, for every query.
Using what? Sorry.
Use Post method.
Yeah.
Because you need to pass some data in JSON, JSON-like language. Yeah, it means that you couldn't use built-in HTTP caching mechanism. So does GraphQL have some caching mechanism out of the box?
Not out of the box, but the specification gives you some tips. But indeed, what he said is very true. You cannot cache on the HTTP layer. Makes no sense because GraphQL is always using Post because you're always sending information, which is the query and some variables to the server. So your cache strategy is actually going to lay in your backend. So front-end client cache with HTTP is not yet a good idea, but you can also do with the client. Since the schema and etc. is so smart and it's so typed, you might have a JavaScript client, for example, capable of caching certain parts for you. And in your backend, of course, in the resolvers or in a previous layer, you can create some database caches and some other things like that. It is indeed one of the drawbacks from GraphQL on this side, but of course other solutions are in place for solving it. But it's possible to cache. Yeah,
and I have a final question about mutation. who decide what the backend should respond after mutation? I mean, if I mutate few entities and I need to, I need to respond with multiple entities. Is it possible?
Yeah, it's all depend. You can only return one object. So let's say you return the human. So this means the user can query everything which is below human. So let's say you mutated a starship, but you are returning a human. So you can go to the human, get starship's connection, and then see the starship's updated. So if you really want to make something specific, you can always create forking of your objects. So that's actually going to depend on how well you're going to design your model's interconnections. So yeah, you can return one type. If this type is human, the user can get everything from human and below in all depth, as we saw before. But yeah, you have to decide which type you are returning. You can even create a new type. So let's say I created a review. I can create a review object, a new type object. And then on this type, I can, for example, return movie and then review together with all the points. So that's a way for you to kind of give the client more information. But of course, be careful. You don't want to create just objects only for this thing. You want to make them useful as well. So it's possible. The power is completely up to the developer. Because when you have the resolver, there you do anything that you want to do. And that's really nice.
Thanks.
Thank you for presentation.
Where are you?
Usually we have a lot of Doctrine Schema in a Symfony application. Do you know any tools to mapping GraphQL?
For what, sorry?
Mapping GraphQL schema to Doctrine Schema.
Sorry, I don't get it.
Ask about mapping between Doctrine and GraphQL.
Oh yeah, of course. Here we define the types manually. But if I'm not mistaken, someone made a comment on the Symfony console that you can actually translate the doctrine entities that you have to API to GraphQL ones. You might be able to do something dynamically, get inside the library, but I wouldn't recommend that because sometimes you want to have some differences. And then let's say you get data also from files, you get data from other cache, you get data from other APIs, and that's something that GraphQL can offer you, like go to multiple places. If you limit your whole GraphQL API to just the database, yeah, then it's going to be hard for you to make something better afterwards. So you might have a bit of duplication, but it's not too much.
Any more questions? Ребята, еще вопросы?
Sorry, hello. Can I use this GraphQL language along with some graph database like Neo4J? Do you have some experiments maybe?
Yeah, good question as well. It is possible. So some GraphQL guys, they created a translation. So you can actually install a plugin on Neo4j which accepts GraphQL language. So you can basically send directly to Neo4j. It's not out of the box. You just install this plugin, but it works. So let's say he has the same problem. He was talking about the n+1, and you have a backend in Neo4j. You could use your promises to create a query for Neo4j in the end and then solve all your resolvers at once. So it's possible.
So there are some solutions already? Like
Yeah. This plugin already exists. You can just look for Neo4j GraphQL. There is a plugin. You install it out of the box. No hassle. I'm actually really glad with all the questions. A lot of complex things. I'm lucky to answer that.
Also, a question about MarkSteps. So just imagine we build like an API for a public API with heavy load, where we have millions of people who are using it, and for some reasons, for example, we said that MarkSteps is around 100, and it's okay, it's fine, but at some moment we start to realize that it's too heavy for us. And usually if we have some API changes, we just say, hey, we have API version 2 and just please use it in months or so. But in this case, if we just want to change depths, it will cause some errors. for people. So it's like seems like very tricky place to play around.
Yeah, you're right. But of course, we are using the Symfony expression language there. So you can actually take over the whole complexity thing and put it in another service. So you can kind of experiment with your clients on like limiting different depths. And one other powerful thing from GraphQL, it's possible to return partial data. So if you already have the complexity running in your API, your client kind of knows they can have partial data already. So they probably already have some kind of mechanism to go and fetch the rest of the data. You can even make this automatically. So let's say every time you get your data cropped, limited by the server, your client says, oh, okay, I got some limited data, I'm gonna go again and ask for the rest. So of course, this is still a relationship between your clients, but you could, for example, in a hacky situation, create a new field with a different complexity and then migrate the users slowly to this new one, which is, for example, smart, and then you say, hey, use this new object here because this one is faster. And then you're going to see people migrating to them and etc. But it's indeed an edge case that you could have. But again, the GraphQL is it's only the way to communicate to your server. You're going to have to be creative on your code as well to solve all the situations.
What about testing or mock for GraphQL? Is it?
Well, I don't do mocking on it. I like to do some kind of functional tests. So if you remember on the beginning, I showed like a query which was just a string. So I basically do that on my test in a file. So I create a file like get all humans test dot GraphQL. So then my IDE can type hint it for me. And then I create another file which is the expected JSON response, for example. And then I make just a bit of PHP code, like to read those two files and inject my variables depending on my test, like data providers or something like that. And then I just run those tests and get the expected output. What you might mock is your repository, is the things underlying beneath it. But then, for example, let's say you want to return a date. So then you have to mock your repository and force a date time, so then the JSON file has the same date, for example. But yeah, it's up to you. But it's really, really possible to mock.
Thank you.
Last questions. What about to maintain the deprecated scenes? So I mean, for instance, if you work a long time with some schema and schema full with deprecated scenes, how you clean up these deprecated scenes after some time?
Yeah, that's up to your release cycle. So the same problem as any kind of deprecation, right? You have to inform your users before. So what you can do actually is create some kind of logging mechanism. When you put a deprecation, you could go to your resolver and then start logging every time someone is still querying this field. And you could see which client is that. So then you can kind of make a communication email and say, hey, this is getting deprecated. We are going to remove it in 6 months. So then what's going to happen when you remove it? The client's going to have a syntax error. So, hey, we don't know this field. And then you break them, they fix it. But that's...
So first time updated client's interface, next time you remove it, deprecates from the schema at all.
Yeah, you could just work like a semantic versioning. You start putting the warnings in your minors and then you remove it in a major cycling release. Other option is just leave them forever, but without all the new features. And then slowly you can see no users are using it anymore. That will depend on your business. If you have a public API, that's going to be quite complex to communicate. But if you have like a closed source project, which you have like a few clients, like a mobile app or something like that, you can manage. I've read something about managing versions on the using React native apps and etc. But I'm not really on top of it to tell you exactly how it works. But I know some people are thinking of some strategies on how to make it better.
Many thanks.
Thank you.
It was great.
Thank you.